Дорогие друзья, дорогие коллеги, добрый день. Спасибо, что сегодня присоединились к нам. И, конечно, присоединившись, вы уже знали заявленную тему. И мы ведь говорим по-русски, да?
Ну, пока да.
Пока
но
да, а потом мы
we will speak
переключаемся.
English on
Да, поэтому начинаем по-русски, а потом переключимся на английский язык. Но тема заявлена была Practical Tips in Teaching Math in A.C.E. Environment. Вы знаете, математика – это такой предмет, который в школе завтрашнего дня, как правило, берут на начальном уровне, иногда немножко на среднем уровне, и не все забираются на старшие уровни. Нам кажется, что весь опыт нашей работы с учащимися, с преподавателями говорит о том, что то самое интегрированное обучение предметному содержанию и языку, оно предполагает, прежде всего, изучение всех предметов на английском языке и такой области, как математика, которая до сих пор, и я думаю, что останется навечно одним из главных и основных предметов в итоговой государственной аттестации. И поэтому формирование, во-первых, понятийного аппарата, терминологического аппарата, в том числе фотоаппарата, у меня все фотоаппарат, да, аппарата по математике и по всем предметам естественно-научного цикла, это одна из важнейших наших задач. Конечно, школа завтрашнего дня – это неплохой инструмент в формате пейсов для того, чтобы эти термины дети освоили, эти понятия они усвоили. Но, ко всему прочему, существует еще и необходимость для детей творчески использовать все то, что они применяют, и поэтому наши преподаватели тоже не стоят на месте, и поэтому я с удовольствием сейчас уже подхожу к тому, что будет говорить Евгений Коломагин, наш преподаватель по математике старших уровней, и он поделится с вами на английском языке тем опытом, который у него есть в работе с программой школы завтрашнего дня, в работе с детьми по курсу математическому. Мистер Евгений, over to you.
All right, thank you very much. So from now on, we will continue in English because we are talking about School of Tomorrow environment. And this environment is in English. And we study and teach math here also in English. And I believe that learning math in English provides many interesting opportunities and advantages. But let's start our webinar with a conversation. And I have some questions to you, and I hope you will answer them in the chat. So the first question, what is math? I have a chat here, so you may write your answers. Please don't be silent. I don't want to answer my own questions. Of course, I will, but it will be later. And again, you don't need to be formal. Let's make it informal. All right, since not many responses in the chat, let's discuss all of them together. So main three questions that we have to answer before we will go to the practical tips are: what is math? What does it mean to teach math? And what are properties of a teacher who teaches math? Not a math teacher. There is a very big difference in math teachers and teachers who teaches math. Because in a School of Tomorrow environment, any supervisor can be responsible for explaining math concepts and bases. And usually our supervisors are English teachers. So their major is linguistics, not math. So let's start with the first question. What is math? I believe that math, obviously it's a science, but it's more than just a science. Most of our students, I would say more than 99%, will not use math as a science. The most important thing that math provides us with many tools to analyze the world around us. Math teaches us how to recognize patterns, how to deal with numbers, and our world consists of numbers. Next question, teaching. What does it mean to teach? What is our purpose in teaching? And I also believe that our goal in math, when we teach math, is not just to explain students how to add two numbers together for them to be able to buy something in the shop. No, it's not. Simple arithmetics is not the purpose of math. It's just another tool. Yeah. Math is an analytical tool. It's much more than just simple arithmetics. Think about math as a tool for your life. It can be very useful and important. And a last question, what are properties of teachers who teaches math? Obviously, it will be different from math teachers. Math teachers should have appropriate education. They need to love their subject. They should be passionate about the subject. And nobody expects from an English teacher to be passionate about math, physics, chemistry, or I don't know, social studies. But School of Tomorrow environment makes us explain all of that subjects, and actually we are possible to do it. We have all the tools that we need. The only thing that Learning Center can miss is a teacher. The teacher is a key person in a learning center. You may not have appropriate education like engineering, mathematics, physics major, or whatever, but if you want to learn, if you can adapt, if you are creative and patient, you can be successful in teaching kids. I believe that through these four, adaptability and continuous learning are one of the most important things that you should have. And I believe continuous learning is the most important. For example, I, math teacher with technical education, I learn almost every day. I love to listen to some podcasts. I always have some course going on in my life, or maybe sometimes two. I always interested in finding new problems for my students, finding new ways to teach them, because each year provides us with unique opportunities and challenges. Let's start from the basics. Math PACE. As any other PACE, Math PACE consists of 3 sections, sometimes 4. In really rare cases, it's 4. So usually 3. Each section is divided by a checkup. So usually there are 3 checkups, self-test and the test. So this is a table of contents. And today we will mostly discuss this PACE. This is Algebra 2, second PACE, 1122. The PACE about arithmetic series. In School of Tomorrow environment, there are several ways of assess the student knowledge. So we all know that there are formal and informal assessments. Tests, self-tests, and checkups provide us with a formal assessment. And today we will mostly talk about them. And the checkup provides us with the unique opportunities. So that's how usual checkup in math looks like. As you see, if you compare the math pace to English pace, there are not really many questions. Actually, there are no questions in this particular checkup. And we all know that when we ask the checkup, we need to somehow paraphrase the question. And for example, if we have in social studies, when Byzantium was taken by Turks, and then you have to write the date, 1453. You may ask, what city was taken by Turkish army in 1453? In math, you can't do that. What can you do? And I don't advise this. You may put dots and ask a student to do them in front of you. But there is a problem. So we have a checkup. And we ask a student to find out, is he ready to do the checkup, right? So we have some questions beforehand, and after them, we know that student cannot do the checkup. But if we use the checkup to find out that student can do the checkup, this is a paradox. It's like a snake that eats itself. So there are some suggestions. So first of all, you must be prepared. I recommend to any teacher to go through paces himself. Because obviously we all studied in different schools, we have different environment, we have different textbooks. And you should know what you are going to teach. That's why I really recommend to go through each of the pace, okay, maybe not do it 100%, but at least go through main sections, main formulas, main theorems, main rules, and at least freshen them a little bit. So this is example of my notes for this space. I went myself through all topics in first two sections. I even put page numbers so I can quickly refer during my work in the Learning Center. Then, since I'm against putting dots into the checkup, I created questions according to the topics that they learned into the section before. All of them refers to the formulas and theorems that were in this section. And if I see that child understands everything, I can allow him to do the checkup. When we ask the checkup, we must engage the student into a conversation, because otherwise you don't know, does he understand or not? And our main purpose as teachers to make sure that the child grasps the material. Again, using the material and understanding the material are completely different things. Students can learn the formula can learn definitions. He can learn even answers for the checkup. But the student cannot memorize understanding. So conversation with a student allows us to understand, does he understand it or not? Of course, you must be sure that if there are any formulas, he memorizes it. But more than this, you must be sure that he can give examples, explain it in his own words. Can he solve some tasks that are not given in the PACE? For example, I also prepared some extra problems before the checkup. Actually, they're the same like in checkup, but with different numbers and sometimes with different words. I just change them for synonyms. Checkups are inside the PACE. We don't pull them out. So students, they have access to them. Some of my students, they are prepared for the checkup one day before. They know all the answers by heart. They have all the written solutions in their notebooks. And sometimes they ask their friends to do them instead of them. So all this preparation allow you to be sure that your student understand everything and not just memorizing everything. So what to ask else? So first of all, before the checkup and self-test, we must focus on the formulas and the rules before. I also recommend my students to have a notebook where they can write these formulas, because after they do the test, they must submit their PACE, so they cannot refer to the algebra PACEs in the future, even if they forget some formulas. For example, in geometry, we have special handbooks that they can keep after with theorems and definitions. For algebra, we don't have it. Maybe it will be interesting if your students make such notebooks. Then some sections in the PACE look like this. This is a theory. This is a theory from the current PACE that I talk about. This is a formula for the sum of arithmetic series. This is an example from another PACE. This is a derivation of quadratic formula. As you see, this page provides the full derivation of the formula. This page doesn't provide a derivation. It's written memorize. Many of my students ask me, why is it like this? What is the origin of this formula? Because I understand them. If I don't understand the concept, I will forget about it next day. So our students, they have to draw many connections between them and the math fact. The more connections they have, the better it will be. It can be physical, visual, audio, emotional. The more, the better. So actually, when I prepare for the PACE, I go through such sections, and if I don't know the derivation, I go to usually it's YouTube or any other math textbook to find out the proper derivation. Let's look on this particular example. we have a formula of an arithmetic sequence. One of the main things that you have to keep in your mind when you derive formulas, you shouldn't be above the student. We can use only tools familiar to the student. If you introduce a new concept, our students will forget this and the new concept you just explained to him. So big letter S denotes the sum. This is the first term of arithmetic sequence, and this is the last one. How do I start to explain this to my students? So first, I ask them the definition. What is the sum? And usually they know the definition. They tell me, the sum is the sum of all terms. According to definition. No problem, they know it. They know this. Then I ask them to write it vice versa, in opposite direction. Don't start with the first term, but start with the last one. And usually, what is the difference between the terms in arithmetic sequence? This is a special number D. Just for example, arithmetic sequence is 2, 4, 6, 8, and so on and so forth. So we always add 2. So this is the first term, this is the difference, and this is the nth term. Then I ask them to unpack each of these terms. And our sum will look like this. An plus A1 plus D plus A1 plus double D, and so on until you reach the nth term. And then I ask them to do the same with the opposite formula. And here there can be different approaches. I like to subtract the difference. And as you see, for example, this term and this term, they have plus D and minus D. Oh, by the way, I forgot to add AN here. Sorry. Then this term and this term, they have plus and minus double D. So when you add them together, these double D's, they eliminate each other. And the only thing that is going to remain in this row A1 and in this row AN. So after we add these two formulas together, we add two formulas, we receive double sum equals 2. And after this, I ask them, how many terms do we have here? What is the number? And in half of the cases, I get the right answer. They say n number of terms. It can be 5, 9, but when we talk about general form, it's n. So it's n, a1 plus an. And after we transpose 2 to the right side, we receive the original formula. And after you go through this process with the student, believe me, he will memorize this formula for much more than one day. When I saw it first time, it just stuck into my head. And after this, I cannot forget it. It's just there, because it was so interesting. We must explain to them that math is not about using the formulas. It's all about the origin of the formula. How can we get this? We are not interested in algorithms. We are not robots. We are humans. We are creative, and we have to unleash our creativity. Otherwise, why do we need a human somewhere if we can exchange it with a robot? Another good example that I want to show is using physical objects. Everyone knows the special product formula. In Russian we call them формулы сокращенного умножения. And they are really easy to derive, right? You just need to multiply two expressions in parentheses, and you receive the formula. But there is a problem. They are variables, very abstract numbers. We can't touch them. They don't have physical meaning. That's why I love geometry and using geometry in algebra. Because in geometry you have shapes, you have perimeters, you have areas. You can touch them, they exist. So I hope most of you familiar with the concept I want to tell you. So we have a square. Let me put it this way. So we have a square, and each of the sides are a plus b. I think you already know what I'm going to say after this. So it means that the area of the square is a plus b times a plus b, or a plus b squared. But since the side is a plus b, it means it contains other shapes. Small square with just the side a, and the area of this small square is a squared. Then we have a bigger square with the side b. The area of this square is b squared. And there is a space for two rectangles with sides AB and BA. And we have two of them. So after we add them together, we will receive the formula before. And this really helps the student to remember the material, because it's not only visual and audio. He can touch it. He can feel it. And actually, the tactile feelings are very important in learning. Unfortunately, in our 21st century, when we move to the tablets, gadgets, computers, we don't have it a lot. And this really affects our kids. Another interesting example with areas. Actually, many concepts in our lives are connected with areas and geometry. Let me show you the example in the page. No example in the page, unfortunately, sorry for inconvenience. So there is a formula for divergence series when you have to add numbers that are going to be less and less. I'm talking about numbers like what will be the sum of this series, and so on and so forth. Many students, they don't actually get it. For them, it's just random numbers. They can say infinity, 1, 3, 4, whatever number they think about. Sometimes they memorize the formula, they can answer it. But since we're talking about numbers, they are very abstract. It's very hard to imagine them. And again, if we talk, thanks. Yes. And if we talk about geometry, about figures, we are talking about things that they can touch. So first, let's put a square with the area of 1. So the square will have sides 1 and 1. The next square should have the area of 1/2. This is possible if one side is 1 and another side is 1/2. So this is rectangle. Then we need a square or rectangle with the area of 1/4. So obviously it should be half of this rectangle, and this is a square with sides 1/2 and 1/2. So the area is 1/4. And then we can continue. We can put more and more squares and rectangles. And then you may ask a student, what was the original rectangle? And then he'll remember that original rectangle has sides of 2 and 1. And the area of this rectangle is 2. That's how you may show them that series, they are not that abstract, that students can touch it. And actually, it's a very good advice not to do it yourself. You may engage a student to do this lab himself, to let him cut and arrange and be creative, because it will add some emotional memory into the subject. You may create a bulletin board for such things. It also will help him and other students to understand the concept. It also will engage them in a group work, which also can expand their memorization of this concept. So as conclusion, I would say that when we teach math, first of all, we have to look for students' creativity, for their understanding, critical thinking, and analytical skills. If after they graduate from school, they will forget all of the formulas, it's fine. But the thing that they shouldn't forget, they are successful, creative, and smart. And it's our job to make them that smart, successful human beings possible to analyze the information around us, to teach them how to adapt, how to change and transform. Thank you for your attention. If you have any questions, you may ask them in the chat. If you have any, we have 4 minutes left. No questions for now. Do you have
Okay,
anything?
hey, Mr. Evgeny, as I was listening to you, what you showed in the part of preparation, lots of extra questions. Do you think that English teachers who will be teaching math will be able to come up with all those questions to make sure that the student is ready for a checkup?
Yes, if you organize your time wisely. Actually, it looks very hard, but it's not that hard. For example, you have an equation in the checkup x plus 2 equals 5. Right? This is very simple. Change it to 6, it will be already another equation. It's not that hard. Of course, if you talk about the higher paces like algebra, it's a little bit more difficult, but the concept stays the same.
Okay, so this answers because I was just wondering if a teacher who is not an expert in math would be able to come up with those alternatives. And apparently, yeah, if we go this route, it will be possible. Okay, since we promised to finish it on time. And Mr. Evgeny, thank you so very much for this sharing. And I believe all our listeners and those who will be watching this offline later on will be able to gain some understanding that School of Tomorrow is not about just formulas, not just about applying those formulas, and not about memorization. But this is a good example that, like all those visuals, all those tactile opportunities that you can offer to your students are natural add-ons to the academic process that will expand the experience and that will expand understanding and mastery of the material. And math is one of those examples when you can be creative. Thank you so very much. God bless you, and we'll see you shortly. During our training, we'll also touch on some of those things about math, and our training will be in August. God bless you, and goodbye. And game on. Thank you.